So find the minimum spanning tree. Given a weighted and directed and connected graph with three vertices and two edges, your task is to find the sum of weights of the edges and minimum spanning tree of the graph. The graph is provided as a list of edges, where each edge is represented as U, V, and W. So from U to V with weight W. Okay. Indicating an edge between vertex U and vertex V, and with edge weight W. All right. Minimum spanning tree. What is the minimum spanning tree? A graph that has no cycles, and you can read all the vertices without any loops, and with the least cost. Then with the entire sum of all the edges being minimum. Also, for the vertices, it will v minus 1 edges. Not loops like cycles. Okay, so I need something to store the sum. Then I use a Boolean, visit a new Boolean, ID, store ID, visit a nodes. Then I need a priority to storing the weights and the edge and the weight to it. So this is a new priority queue, same general, and that is going to be from return dot from parent and from a of 0 from p a of 0 and add any arbitrary node. And I'm storing it. I'm storing the weight and the node rather than. So I'm just going to add a new integer that would be 0, comma 0 means nothing for now. And while I can remove any elements from this priority queue, I need to get the topmost array containing the nodes. So that is preview.code, and then the node is topmost one, and the base is topmost 0. If I've already visited this node, I can skip all the iterations. Otherwise, I can just visit it. Say, visited for this node equals to 0. Then you need to start a for loop inside this there for all the nodes, for all the neighbors, and the adjacent node is a greater of 0, and then the weight of this integer is the adjacent node is id of 1. if I haven't visited this adjacent, so it's not rather. I'm just going to add it to the priority. बता रहा हूँ 1 मिनट दोनों स्ट्रिंग्स को ऐड करके चेक कर लो उसमें बस हाँ you have to start you have to wait of this note continuing with what about the over we will add some of it some basic puts to the weight and then I can just return from and then I have to create my the list of lists so and just what if we choose it again array list for in I equals to 0 I less than I plus plus APJ dot add a new array list row in row in edges and u equals to row of 0 and equals to row of 1 and grade equals to row of 2 and then the teacher of get okay that makes sense so get u dot add the u or I see the problem I see the problem this has to be an integer u and inside it it's going to be v on the way and then adjacent of get v dot adds the directed or an undirected so that makes sense u and the way u and the way so by that logic this now has to become and row data I think then it should work I think now that should work so I create the urgency list I add all the elements let's just get this on create urgency list I found the data set before it then the priority queue is set up in such a way that it is going to keep the element with the minimum rate always at the top. This is what the comparator is doing. It is making sure that all the elements, rather all the items inside it are arranged in such a way that the node with the least amount of weight is GFG is at the top. Um, because this is going to compare the first element inside the array that I'm adding it to that I'm adding to the priority queue. And when it is going to compare the zeroth element here, or the first element, rather, at the zeroth index. And that is the weight that I'm assigning to every single node. So based on that, the comparator compares each and every array inside the priority queue or the array to the weight of the node. And then I add an arbitrary node to start the loop. If I've already visited a particular node, I'm just going to ensure that this entire part is executed. Otherwise, I mark it as visited. I add the weight because I know that the current weight that I'm getting amongst all the elements is going to be minimum because of how the priority queue is set up. It is always going to give me the element or the node that has the least amount of weight. I add that to my global sum. Then I iterate through all the neighbors of this node that I have gotten. I take the node, then I take the weight of that node, and I see that if I haven't visited this node before, ठीक है. If I haven't visited this node, I add it in a priority queue, and then the entire process is repeated, and then I can visit it. Sure, makes sense.